Well, this is a workshop that focuses on AI and what algorithmic bias might look like, and so how do you begin to reimagine that learning? And so we have Crystal and Tamara, and they are both going to work with us on better understanding how AI can play favorites. So I'll hand it over to you all.
Thank you, Justin. So we've titled this When AI Plays Favorites. So that way you would understand that there is bias within different types of AI. And using the lessons that I'm most familiar with, math and language arts, but Crystal and I worked in math to reimagine a lesson. And that's what we'll be, and two different lessons actually, and that's what we'll be visiting today. So my name is Tamara, and I am a math and special ed teacher at Dartmouth Middle School.
And
And go ahead, Crystal.
and I'm Crystal, and I just took a position teaching statistics at Cristo Rey, Jesuit High School. So that is where I'm at.
Thanks. Congrats.
And we were going to ask everyone to introduce themselves, but Nicole, I know you already did, so thank you so much for sharing. One thing I wanted to share is that Crystal and I both volunteer for Teachers Empowering Youth Activists, which is an organization that works to help teachers build anti-racist racist classes as well as embed culturally sustaining pedagogy, and all the while empowering students to really take up opportunities to showcase their concerns, their perspective, and utilize their voice. So if you want to learn more about that, you can talk to me later offline. It's Teachers Empowering Youth Activists, TEA for short. We can go to the next slide. So you'll notice at the top of the agenda, we did our welcome and intro. We'll go into our lesson engagement. We'll do some reflection. And then we have our lesson lab in which we support you through remixing some lessons. So this video here talks about three types of bias as it relates to machine learning. So we'll go ahead and watch it. It's a 3-minute video. And as you're watching the video, we have some questions that we would like you to think about as you watch the video. So I'm going to put those questions into the chat.
You can't hear the
Can
video.
everybody hear the video?
Mm-mm.
Hmm.
No, when you share, you have to choose the option to share audio.
Okay. I
So you
don't
can
know.
unshare, and then when you share again, just click the share audio button or box.
Okay. So I'm sharing my screen and oh, I see share sound. Okay. Where am I at? I must have shared the wrong window. Okay, let me stop sharing this. Uh, and let's try it one more time. Okay, so I'm sharing my sound and I want to share my entire screen. Okay, here we go. But why? Oh, there are my windows I want. No, that's not what I want. Okay, here we
Oh,
are.
I was gonna say I could share, but you found it.
Okay, so I'm going to start playing it again to make sure we can hear.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone. Let's play a game. Close your eyes and picture.
All right, so we don't need to watch this again. Let's see.
Okay, so the two questions are, what are your prior experiences with algorithmic bias? What are your key takeaways from the video? Do we want to just stay in the main room or do we still want to do breakout rooms?
No, we could just stay in the main room, I think.
Okay. So sorry to put you on the spot, Nicole, but I'm going to give you some time to think.
Okay.
And then we can just have a chat.
Yeah, the thing that I'm thinking of is this it's like data cleansing called blueberry muffin or chihuahua. And if you think of what a blueberry muffin looks like, it kind of looks like a chihuahua face. So I don't, that's the first thing that popped up with me. And you know, like you need to like start teaching computers like, is this a blueberry muffin or a chihuahua? Is this a beet or bacon? Um, but I think you probably have better examples than I do.
Right. Yeah. So the video did touch up on that. If you're, training um the whatever it may be, right? Whatever you're trying to use, you're training it with only a certain type of representation, then it can kind of skew in one way or another.
Yeah, I think like when you do image generation, it still comes up primarily like if you ask for someone who's dressed like a pirate, like it'll almost always be either a white male, um, or someone who looks very much like that. And so rarely does it auto generate something that is different. So I just think that like that's just one example and that I can think of when like just image generation. I think even when you're looking at like um an explanation for why something happened, like it won't necessarily take it from multiple cultural aspects. It just generally gives you like one segue, and so then you've got to kind of get it back to the middle.
Mhm. Yeah. So definitely talk, whoever right, is training the AI to with whatever data that they've been using or whatever data that they're collecting and using can have these different types of bias intrinsically. And so unless you're mindful, there are some ways that people can be mindful, but in order for us to really understand how this applies to this to the lessons that we're doing, I'm gonna take you into the context of what's going on here. So this is my little part where I'm gonna say what I do. So I've been teaching at Dartmouth Middle School for 10 years, and I've taught self-contained special education, and I've done co-teaching, which is a part of the inclusion model, where a special ed teacher, teaches with a general ed teacher. And I've been doing that for a few years now, and I do that for math more specifically, and I've also been working utilizing the college preparatory mathematics curriculum the entire time. So Crystal and I, both having backgrounds in middle school mathematics teaching, thought, how can we make our curriculum, more specifically this curriculum that I've been teaching for years, that feels inaccessible and a little bit irrelevant for the students that I'm most trying to reach? How can we make it be more accessible, more relevant? And, we've called it a remixing. And that's how we came up with these lessons.
And Tamar, do you want to talk a little bit about, well, I guess you talked about the push-in model. So to add to that, I came in, I kind of worked with Tamara and we designed these lessons, and then I came into the classroom. So we implemented these lessons with the lesson you're going to see right now with, first with her special ed class of about 11. I want to say there are 11 kids in that class. And then we did it the following day with the general ed class that Tamara pushes into. So at every point, like when we did these lessons, there were at least two teachers in the room. There were three teachers in the classroom when we pushed into the general ed class. So that's kind of the context. And we actually titled the lessons were in two parts. And we titled them, Does AI See Us? And Justin, you actually mentioned AI image generation, like when you put a prompt into the image generator, often it gives you one type of person. And I noticed that as well. So I actually last spring took the KCI capstone course. And one of the activities we did in that course was prompting an AI image generator and kind of seeing what comes up. And it disturbed me, like how many people, like many identities were left out of the images that came up. And so that was kind of floating in the back of my mind for a while. And when Tamara and I got together and decided to put this lesson together, the first thing we did is we opened her textbook and we saw a lesson on probability. And we said, oh, we could connect this with the AI image generation. So down here, you see the actual agenda we did with the students. Our learning objective for them was to critically analyze AI image generators. And in seventh grade, students are introduced to probability and the difference between experimental and theoretical probability. So we wanted to get them to understand those differences while simultaneously looking at AI. And so what we're going to do is we're going to have you put on kind of your student hat right now, and we're going to walk you through part of the lesson. And actually, I believe in the CPM textbook, the headline is actually possible or impossible. That was the headline of one of the lessons. And so the term probability is introduced as this term to explain whether something is possible or impossible or anywhere in between. And students are introduced to a number line. So you're my students right now, and I am going to introduce this number line to you. So students, when we look at probability, When something is impossible, it has a probability of 0. And when it's for sure going to happen, there's a probability of 1. And then we have all kinds of fractions in between. Um, and so if I asked you if we're flipping a coin, what's the probability that you would get heads? We would say the probability is half, right? Because half the time you would get heads and half the time you would get tails. Um, but for different things, like probabilities can be anywhere in between. And sometimes we'll give probability in fraction format, decimal, or percent. So what we're going to ask you to think about now is if we prompted AI to generate an image of a California seventh grader live streaming a video game, what do you think would happen? So that's the exact image prompt we gave to students. And actually, just like with you, we spent some time talking with students about their experience with AI and AI image generators specifically before we got into this. So we're going to go through a few scenarios and what we'll ask you to do in the chat box. And right now I can't see the chat. So tomorrow, if you can monitor the chat here.
Yeah, I can do
But
that.
the first scenario is scenario A. What do you think the probability is that there will be a person in the image? And just go ahead and type that into the chat box. You can type in any
Okay,
number
we got
between 0
one.
and
Thank
1.
you, Justin.
Oh.
100% and 1. Thank you,
And as
Nicole.
adults, I think we have more experience with this, maybe because we're just people who have worked with AI before, but a lot of the students didn't say 100%. A lot of them thought, oh, maybe AI would get it wrong, and I'd even put a person there. So what we realize is that their experiences, even with AI image generators, is not very much. Okay, what about there being a screen in the image? So seventh grader live streaming a video game. Okay.
Okay, one,
Actually, I
one,
can see
one.
the chat now too.
Oh, you
And I
got
can
it?
see. Okay. What about the person in the image has wrinkles and gray hair?
0, 0, 0. Thank you.
And what y'all are saying is what we expected the students to say too. And I was super surprised, like their lack of experience with this. Okay, what about the person who's wearing glasses?
Oh, I like this. 0.6.
Yeah, okay. And Jen,
And we
we
got a
saw, so you
2.
said you wrote 2, but you have to put a number between 0 and 1. So maybe 0.2?
0.8. 0.2. Yeah. Thank you, Jen.
Okay.
Okay. Oh, I think she meant half. So 0.5.
Yeah. Ooh, so high probability. Y'all put high probabilities there. Okay. And then we actually I don't remember with the general ed group tomorrow if we got to this one, but I realized with the special ed group we were running out of time, and so we didn't even get them to think of their own event. But our idea here was for them to put in something that they are interested in, like maybe the student has curly hair or the student has a blue shirt on, right? So they had to come up with their own event. That was our idea.
Mm-hmm.
I think I just rushed them along,
Can you
if
explain
I
that real
remember.
quick, Crystal? Sorry.
Mhm.
Can you explain what the E was again?
So our event was just for the students to come up with some event that some possible thing that could happen. So maybe the
After
student,
generating the image.
yeah. So maybe
Yeah.
the student is wearing a red shirt, or the student has curly hair.
Got it. Got it. Got
So
it.
just come up with our own event. And then the last one was the person looks like me. And of course, all the students in the room look different. And
So far we've got 1, 0, and 0.2.
okay. So Justin, you said they'd have hair, so that means they won't look like you, I think. Okay.
Thank you all
So,
for participating.
so that was kind of our intro to that, and it's like almost exactly models the lesson from the textbook. So at this point, we had students go into their Chromebooks and experiment with image generators. And because we realized like they had some inexperience with this, we actually went into Canva together. For you, like everyone here seems like they have a little bit more experience. So, you are allowed to use whatever AI image generator you want. This exact slide came from the student lesson, and we think it's a good practice for students to have team roles. So those were the team roles that they used. But they opened up their Chromebook. We showed them how to type the prompt into Canva AI. If you log into Canva using your Google account, like this is your homepage, and you can type the exact prompt there. So what I want to do right now is just pause and give folks a chance to type that exact prompt into
And I put it in the chat if you are able to
yeah,
copy and paste.
into your AI image generator, whichever one you want. And we'll know you're done because you'll start typing stuff in the chat box about what you notice.
Oh, Justin left. Uh, sorry, I'm just catching up.
So I put into the chat the link for Canva AI.
Yeah,
So
and feel free to
it'll take you.
use your preferred tool if there's a tool you like to use or a tool you would use with students or that your students are used to using.
Yeah, whichever you choose. And
Yeah.
then also there, I put the prompt so you can copy and paste it. And then once you utilize, or once you've generated utilizing whichever AI tool, what does the team notice, meaning us here, really? And are you surprised? And so you can share or type your response to that in the chat.
Yeah, feel free to
Okay.
come off mute and share out loud as well.
Okay. Yeah, it's loading. Yeah. Does anyone want to share what has loaded for them?
I can actually do it like in live.
Yeah,
I'm
there.
curious what's going to come up. Oh,
Oh, there we go.
actually, I did not mean to advance to this slide. Let's go back. I want to do it live right now to see if something different comes up when I do
Yeah,
it
that's a good idea.
today. So let's see. Okay, what did I do wrong? Am I not in Canva AI?
I think you are, but you can also specify an image.
Because I didn't. Okay.
I've also found that I think AI generation is a little expensive, and so some of these AI companies, like unless you're very explicit, like this is what I want, I insist, they might not generate the image.
Okay.
Yeah,
These are the ones I got when I generated it 4 months ago. You're not going to give me new ones, Canva.
Yeah, you can force it. You can say, give me new images.
Let's see.
There we go.
Okay.
Wow, that is exactly how I imagined it.
My kids last time were more diverse, actually, 4 months ago.
Hmm.
That's great that it's more diverse.
Um, so so it's interesting when I did it live with the students, these were the images we got.
Hmm.
That's way better.
Yeah. But so yeah, this is what they look like. And so yeah, we had that discussion with students like,
It's interesting because in California, aren't we a majority minority state, right?
mm-hmm,
So the fact that they don't capture that is interesting.
mm-hmm. And then I see in the chat, Jen said my images are all boys with brown hair. They all have headphones and one's wearing glasses. And I think that's one of the things the students noticed too was the headphones. Because we didn't ask for that and they just assumed that they would have headphones. And they have nice ones too. Like these seem like some middle class kids. Um, they're not just earbuds, right? The kids actually picked up on the headphones when we had that conversation. So I actually, like I said, this idea for this activity came from the activity we did in the KCI course that I took. And I thought it would be powerful to do with the students. And I think Tamara and I sat down over the summer to talk about how we wanted to do this. And I had recently done that course, so it was fresh in my head. And like I said, these are the images that came up. Are any of us here surprised?
I'm surprised these were the first ones to come up on any image generator.
Yeah,
Okay, you're
Yeah.
surprised that about the ones that came up when the kids and I did it live. Okay.
I'm pleasantly just surprised to see girls and minorities. Um, I I'm wondering why all the yellow shirts though.
Mm-hmm. And I wonder, like, if it just generated the first kid and it built the rest off of them.
Yeah,
Like,
it could
I
be.
don't, it's just weird how it happens, right?
Yeah.
And we talked about like classifying them by gender. And some of the students were like, oh, one of these kids looks gender neutral, and that's very California. Um, like, so I, I, yeah, like it's very interesting. So from there, I'm just gonna run through. We're not gonna do the rest of the lesson with you, but I will run through like how we walk the kids through the rest of it. We had them actually do this on a worksheet. We had them tally based on the perceived race or ethnicity of what came up, and also gender expression. Um, And then we asked them to come up with a metric they care about. This was the part that kids had trouble with, like, because they didn't understand what we meant by another metric. So it took a lot of time for us to get them to come up with something. And a lot of kids ended up just using the one we have here, which was wearing glasses. Um, but they classified the images, and you can see our team roles here once again. And then once they classified these images, we introduced this idea of experimental probability. We just ran an experiment. We had AI come up with a bunch of different images. And so we just had the students continue to generate images over and over and over again within a time limit. And then when their time limit was up, they wrote the probability in a fraction form, right? How many kids came up appearing Latina, Latino, or Hispanic versus how many were there in all? And like we actually we focused on these two metrics here. Um, and then we um, showed them some data. So this comes from the California Department of Education website, and this is what California students look like. And we asked them to do a little bit of noticing and wondering here. What do they notice? What do they wonder? Like, what's going on here? And then we introduced the term theoretical probability because theoretically, based on the fact that California students look like this, um, theoretically, like over half of the images generated should be Hispanic or Latino, Latina. And then it wasn't, right, for the images that came up for them. So we just asked them to consider like why, why was our experiment not matching theory? Like what was the reason for the mismatch here? Um, and so that's how we got them just to be a little bit critical of the AI image generators. So that's our next slide. There's a sentence frame that we gave the students. We asked them, is Canva AI biased? Um, some of the students said, no, Canva is not biased itself. Like they had some good reasons for saying yes or no, but they were asked to bring the mathematics in there. And Justin, I see your hand up.
Yeah, I had a conversation with someone today, a school leader, and he was, trying to figure out present this to how to present AI to the broader school. And I thought that this would be a really good activity for them to do because of just like it hits home with students to be able to visually see bias and also hallucination and the AI, like it's not perfect. So, like I feel like this is a really good activity to do with students. And then to have them come up also with like case, even if like you look at this, like how do you use AI or how, if you use AI in the classroom, how would you be critical of it, or would you be critical of it?
Hmm.
So just something that came to mind.
Yeah, that's like a great comment. And it is a great way for teachers to engage with AI themselves, like before they bring it in with students.
Yeah, and it's important to get in front of this because like once kids start using AI, and they see all these biases, yeah, they get
Yeah, and they're
diagnosed.
just sometimes some kids just take the first image that comes up when they use the image generator. I think when we asked the students if they had experience, one of the students said, "Yeah, I had to help my sister with something." And so I typed into AI and I pulled up an image and I said, "Oh, did you do a lot of details with it?" And he's like, "No, I just kind of gave her the first image that came up." He's like, "I don't." And so I think their kids maybe are using it as a shortcut for things because it's cool. But yeah, like
Yeah, that,
it's it is like important for them to be critical.
it is.
So one of the important things for us in our closing was, okay, if we believe that AI is biased, then what can we do about it? Because I think it's not good to introduce a social justice issue to students and then say, oh, sorry, so bad, too bad, so sad. Like AI is biased. There's nothing we can do about it. So we gave them a couple actions they could use. And these are the videos we showed them to give them some action. So we're not going to play these videos right now, but they're pretty short videos you could watch on your own when we share the materials. The first video is a kid their age talking about algorithmic bias in general. So not necessarily image generation, but just general algorithmic bias and why it happens. And what he suggests is, hey, like a lot of these apps like have thumbs down feedback things that you can push and like say I don't like what I was given, or like there are feedback, like you can actually give feedback. So his suggestion is to give feedback to the apps and say like I notice bias here, like then app developer fix it. um and then we showed a second video of how to generate AI images And the girl in this video talked a lot about specific prompting and like being very specific on what you want. Because if you recognize that there's going to be a bias here, then you need to explain to the AI exactly how you want the California student to look. And maybe not just say California student. Or if you prompt it one time and it gets it wrong in your opinion, then go back and prompt a little bit more detailed. Um,
Yep.
so we then gave the students that choice of two things to do. Tomorrow, I don't remember like any of the students doing the feedback thing. They were also interested in prompting. Um,
Well,
Real quick, in
oh, go
just a few
ahead,
minutes.
Nicole. Did you have a question?
Sorry, I'm so sorry. Real quick, in just a few minutes, I have to get going. But I'm really impressed with the material that KCI has put out with the Learning Pass, and I'm excited to go through the recording.
all right. It was great having you here, Nicole.
Thank
Yeah, I just want to give you
you.
a heads up.
Yeah, and
Uh,
please reach out when you get the materials.
yeah.
We'd love to collaborate.
Definitely.
So I do recall working with a couple students and saying, hey, why don't we say someone from San Jose and see what we get? Why don't we say um, San Jose, California seventh grader live streaming a video game, who, whatever it may be. So I did help few kids do a couple prompts, and they all kind of were coming up with a bunch of different things.
Yeah. I think one of the students, like he who happened to be Asian, like he was very specific and he wanted the student to be playing cards or something like that. And he did a good job of getting the student to look like him in the end. We want to give students some agency there and not just say like it's all doom and gloom. So I know we've done a little bit of reflection as we've gone through. But as you're here, Nicole, I don't know when you have to leave, but I know you have different content standards, you have different things you teach, and um, if there's a way you might use this exact content, AI, image generators, for teaching what you teach.
Yes, absolutely. So in cybersecurity, we also go over ethics,
Okay.
and I feel like this is an ethical conundrum.
And I'm glad you brought that up, Nicole. I actually just yesterday taught the lesson with a group of my students, and a bunch of teachers did it. It was like district initiated to create a personal AI ethical statement.
Yes.
So we watched the video, we talked about it, and I walked my students through creating their own personal statements on how to really hold themselves accountable, but also be very critical of what they're using.
I think that is so important. It's hard to extract that from yourself. Like, what do I really stand for? So that's good job on doing that.
Yeah, I mean, well, my district, Lisa Delapo, she was the one who sent it out. So I would say, it does come down to what are your values, and how, much are you gonna hold on to them? And some students, they don't really, they're just like, what, So it was an interesting conversation, which is good to have no matter what.
Yeah, this is good. I think that a lot of this stuff I can use in my cybersecurity class. So I'm excited.
Right, so we're not going to go into breakout rooms because there's not too many of us here. Um, but what we will do is we'll go into now a little bit more lesson engagement and we'll take you into part two of the lesson because, like I said earlier, this is a two-part series, and I'm going to turn it over to Tamara right now to talk about how we pivoted and talked about AI facial recognition technology.
Thank you, Crystal. Okay, so as mentioned before by me and Crystal, we worked on this lesson to really utilize the content area, which in this case was how can we help students reinforce what they're learning with conversions of percent, fraction, decimal, but also being relevant and utilizing something that is very much being talked about and continuing on this kind of critical path. So in this case, does AI see us? And this one was quantifying bias in AI facial recognition technology. So as I mentioned before, applying fraction, decimal, and percent representations. As you can see on the bottom, that was the agenda, kind of like the steps we walked through the students with a specific learning objective. We can apply fractions, decimals, and percents as we understand bias in facial recognition AI. So creating this lesson, Crystal really was the one who spearheaded this whole thing, but you can go to the next slide. Thank you. So we showed students these images and asked them what do they notice and what do they wonder? And, do you recognize these people? And some of them actually, they did not. They couldn't name them. But I was like, I'm sure you remember who these people are because I had these students last year and we've read articles about different things in our math class specifically. And there's always references and little videos specifically to Black Panther. So although they couldn't name them, I knew that they recognized a few of them at least. You can go to the next slide. So there is this whole critical analysis that's being really, I think, spearheaded by a lot of Black women in AI who understand that there's bias, intrinsic, unconscious, and in our case, it lends itself into the algorithmic bias. And one woman in particular is Joy Abulawini, and she pointed out that there is some facial recognition that isn't doing the best. So she created some scorecards, and we asked students to reflect on what you notice about the data for detected age, gender, race, and the total scores that came up. So you can kind of just go through the next ones. And as we go through these slides, you can kind of just take a quick look at each of the numbers there. I know it's tiny to see, but we had this presented in my classroom. We have a huge TV, so the students were able to walk up to the TV and look and see, oh, is it a yes that it was detected correctly, or was it a no? And each of these rows are different types of facial recognition. So how well and how effective and how accurate is it? And one of the things that we discuss is, what are you wondering? And some kids were wondering why. Okay, we can go to the next few slides. And I noticed we had someone else join. Welcome. Please introduce yourself in the chat if you'd like. Name, where you teach, what your content area is, and we're going to keep right along until we get to our next reflection. Okay, so as mentioned before, there's scores. So each of these different types of facial recognition did not actually do very well. Some of them did better than others, and none of them were, as we can tell, as educators looking at the fractions here, they weren't truly accurate. So we had the students look at the data, then we prompted them with these questions. First being, how was the score for each row calculated? So they could think critically about what are the numbers there and what are they seeing and how that score came about. How was the total score for each Wakandan calculated? How would you convert the total scores to percents? Are these good scores? And then once we go through that, students are able to take what's presented here, recognize that, okay, they get a point for each of, if it's correct, detected age, gender, race, and that adds up for the total score over 4, and then converting that fraction into a decimal or a percent. And then how do you think these AI tools had trouble seeing these women correctly? Or sorry, not how. Why do you think these AI tools had trouble seeing these women correctly? Based off of our prior conversation, which was the first lesson, and hoping that students would be able to understand that there may be some factors, including the algorithmic bias, that come into the mix of this. We had that conversation.
Maybe you explained this already, but why did the IBM model and the Microsoft model have NA for race?
I think it just couldn't identify. I don't know why.
Hmm.
Do you remember, Crystal?
Yeah, we had this conversation with the students too because they asked why was it NA, and we said, well, maybe that software didn't claim to be able to identify race. Like maybe that wasn't a component of that software. Because I don't know, I guess I could have gone in and done a little bit more research on how on what was there. I maybe could have read Joy Buolamwini's paper, which I didn't. So that's kind of what we landed on with the students. One of the biggest things is like they were shocked that like 2 of the software didn't even detect this character at all. Like just didn't know she was there, which was interesting. And they were shocked. They're like, she's not Asian. Like, what do you mean Asian? Like, the AI can't tell that she's not Asian, and like they think she's white. Like, so like the kids were kind of outraged, like that it was so terrible. Now, to put that out, like Joy Buolamwini came out, her gender shades research came out in 2018. So that's when she kind of exposed like this facial recognition software and said how terrible it is. So hopefully things have changed by now, like because we're a little bit removed from that. Tamara, is there anything else you wanted to say about this slide, or should we move on?
I'm gonna just put that link in the chat that you put there. That's all. If anyone wants to look more closely, we can go to the next slide.
Okay, so I'm going to go ahead and talk about this here because when we say facial recognition AI, I want to point out that certain facial recognition AI is pretty accurate. So if you use facial recognition to unlock your phone, that's what we call one-to-one facial recognition AI. And because you take pictures of yourself, you take several pictures, like, and you train the data on you, or train your phone on you specifically, it's pretty good at knowing who you are. And that works really well. Although for my phone, I know when I put on sunglasses, then it has trouble detecting who I am, right? But it's pretty accurate. That's different than the facial recognition AI that we are talking about and that Joy Buolamwini was talking about in her gender shades research. So she was talking about one-to-many facial recognition AI, which is the type that helps to find matches in a crowd. And it's often used like law enforcement is sold like these facial recognition AI packages, like to help them apprehend criminal suspects. And if they're that terrible, like at detecting people, then we can imagine like how are you going to get the bad guys properly? Like if the AI technology is not good. The one-to-many types of facial recognition AI are used in airport security, and also like some building entry packages like are being developed where people can walk up to their building and just look and get in to their building with facial recognition AI. And so that's obviously the facial recognition AI has to be trained. And so we offered students, I wish we would have actually spent a whole day on training like facial recognition AI. So if we had to go back to teach it, we might have had spent a whole day having them play this AI for oceans. But it's actually a really good free thing that's been developed, like just to teach students how training works. And I think a couple of the students played the AI for Oceans game during it was some study hall period that we gave them an option to play it during. And when you play that, you can really see what can go wrong with facial recognition AI training. So I'm going to turn it over to Tamara to talk about what we did next.
So just as we had provided those other photos, we asked the students, well, do you recognize these women? So, and how well will AI recognize them? So looking at these ones here, we can see, all right, these are pretty famous and well-known Black women of society. And like the other photos, you might not know exactly their names, but you can recognize them. And the big question is, how well will AI recognize these women? So you can go to the next slide. Crystal and I did this with my students in my classroom, and I teach 7th grade math. So part of that curriculum obviously is like making sure that they are able to do the calculation of converting decimal fraction and percent, as well as calculating likelihood. So providing students with the scorecard and then providing students with the table, we ask them to tally. Do you think that these women here, these 6 women, were accurately detected? And do you think that they got correct gender? Yes or no? So what we're going to actually do, and we have a poll to get participants to do some tallying. I don't know if we want to do that now, but what we did was we had the tables and the pictures posted on all the whiteboards around my classroom. And so students were able to go from picture to picture and put a tally mark on yes or no for correctly detected and correct gender. And do we want to do the poll or do we want to just keep going?
Sure, let's do the poll.
Okay. So I'll add this link to the chat. And you can go ahead, once you click it, it'll take you to a Google form. How well does 2017 facial recognition AI detect these famous Black women? And so you'll just click either gender correctly detected or gender incorrectly detected or not detected for each one, and then submit. And once we have that data, we'll look at what everyone puts. And then for the students, after all of the students went around and tallied it up, they got into different groups. And I don't have many students because I have a special ed class that's self-contained. And the inclusion collaboration class has a lot more students. It's about over double the amount. But these students, I had to mix the groups up a little, and so they were definitely working with each other. And it was myself, Crystal, and my instructional aide in the classroom. So we were able to keep the students on task in that fashion. So once they added up all their tallies, they got the total of yeses and nos for correctly detected and correct gender, and then they were able to put them in fraction form. We converted them to decimal and fraction. So students worked on that after being able to participate in this poll.
I'm gonna tab over to the survey and see. We have 2 responses so far. So
I'll just do it real quick.
yeah. Well, you already know the answer.
I know, but I'm just clicking. I'm not really looking at it.
So it looks like Oprah
There you go.
Winfrey was, most people thought her gender would be correctly detected, but one person thought it wouldn't be. And for Shirley Chisholm, everybody thought her gender would be incorrectly detected. Okay. For Michelle Obama, which I think that was a picture of her in high school. So that people thought her gender would be incorrectly detected 100%. And Ida B. Wells, which was a woman who wrote about civil rights. Looks like it's evenly split. Some people thought she wouldn't be detected at all. Gender incorrectly detected and gender correctly detected. Same for Sojourner Truth. And then 100% of us said for sure AI would get Serena Williams right. All right. Are you ready for the answer? All right, so and tomorrow, do you want to do this slide?
Yeah, yeah. Okay, so for um as a
Or I can talk
oh
here
wait.
if you want.
Actually, go ahead. Sorry.
Yeah.
I thought I was gonna go over
Yeah. So
something else.
I
Go
think
ahead.
we've talked a
Sorry.
lot about Joy Buolamwini already. So we can just kind of go through this quickly. But Sojourner Truth was an abolitionist and suffragist. Like she was actually a former enslaved person who was born into slavery. And she was famous for Ain't I Have a Woman speech, which is something you can look up. We're not going to show you that right now, but she's very famous for this speech she gave. And so Joy Buolamwini, who is a computer scientist and also a poet. She calls herself the poet of code. Um, and she's the one who did a lot of this research to expose gender AI bias. She herself like came up with her own modern rendering of Ain't I a Woman, kind of in honor of Sojourner Truth, and also to kind of expose like that women aren't seen in AI the way we want them, or the way we want to be seen. So this is her poem. We're going to watch her poem and we'll get the answers to the poll that we did. So let me go into full screen here. And I'm going to pause a second. Can you all hear? Okay.
My heart smiles as I bask in their legacies, knowing their lives have altered many destinies. In her eyes, I see my mother's poise. In her face, I glimpse my auntie's grace. In this case of deja vu, a 19th century question comes into view. In a time when Sojourner Truth asked, "Ain't I a woman?" Today we pose this question to new powers, making bets on artificial intelligence, hope towers. The Amazonians peek through windows blocking deep blues as faces increment scars. Old burns, new urns, collecting data chronicling our past, often forgetting to deal with gender, race, and class. Again I ask, ain't I a woman? Face by face the answers seem uncertain. Young and old, proud icons are dismissed. Can machines ever see my queens as I view them? Can machines ever see our grandmothers as we knew them? Ida B. Wells, data science pioneer, hanging facts, stacking stats on the lynching of humanity, teaching truths hidden in data, each entry and omission, a person worthy of respect. Shirley Chisholm, unbought and unbossed, the first Black Congresswoman, but not the first to be misunderstood by machines well-versed in data-driven mistakes. Michelle Obama, unabashed and unafraid to wear her crown of history, yet her crown seems a mystery to systems unsure of her hair. A wig, a bouffant, a toupee, maybe not. Are there no words for our braids and our locks? Does relaxed hair and sunny skin make Oprah the first lady? Even for her face well known, some algorithms fault her, echoing sentiments that strong women are men. We laugh, celebrating the successes of our sisters with serena smiles. No label is worthy of our beauty.
Okay. I'm going to pause and let us kind of just take that in. And we'll do a little bit of reflection. In just a second, I'll turn it back over to Tamara to reflect, but we talked about some of the problems with facial recognition AI with students as we were going through this second lesson in our series. And I just pulled up this data myself. So in the past year, there have been at least 8 recent wrongful arrests from facial recognition AI errors. And most of those wrongfully arrested were Black individuals. So that is a Washington Post article from 2025. This is not a long time ago. This is really recent. And based on Joy Buolamwini's research, which is a little bit more dated, facial recognition errors have been between 25 to 47% for dark-skinned individuals and are highest for dark-skinned women. So as you saw, like in Joy Buolamwini's visual poem, all of these famous women, the AI got it wrong, but they're famous women whose pictures are plastered all over the internet. So it just like begs us to question things. Just for a contrast, the error rate for light-skinned men is less than 1%, basically.
I know I've seen, I think NPR did a whole series on this, of bias and just how much there actually is, and that the software being sold to these police departments and to other law enforcement agencies is so biased that it almost is like why even have it?
Yeah, and I think that definitely goes back to what Crystal was saying about questioning, if there is something that is so biased and so racially skewed, what's being done to kind of recorrect that skew, and who's doing it? And I think that's really the good work that Joy Buolamwini and others have done. And the hope is that people think critically about their usage for sure. Any other thoughts before I go to the next slide? Okay. So, as I mentioned at the beginning of this workshop, what Crystal and I have really been trying to do is build culturally sustaining work within the classroom and provide opportunities for students to really access um, what we're learning, either mathematically or in language arts or social studies or science. But for me, it's mostly in math and how can we provide different types of on-ramps. And for me as a special education teacher, how are we doing this while also providing different ways of showcasing what they know and learning, sharing, and producing. So to that point, culturally sustaining pedagogy and universal design for learning in mathematics is something that we basically have implemented. It's something that Catherine Yee and Lauren Rigby, Suzanne Huerta, and Claire Engelhard, they actually produced this paper, Culturally Sustaining Universal Design for Mathematics Learning. There are a few things in doing this type of approach to provide an inclusive classroom. And most importantly are the three that are listed here. Multiplicity, which, oh, sorry, can you go back one just really quickly? Multiplicity, belonging in community, and justice by design. So you can go to the next slide. Thank you. So here is a list of some examples of culturally sustaining UDL in the classroom as it relates to UDL's principles, which is multiple means of engagement, multiple means of representation, multiple means of action and expression. So these are a few that I took that are actually from the paper that they wrote. I added a couple things, for example, the link to the Funds of Knowledge website, if anyone wasn't familiar. But go ahead and read through some of these. These are ways that you can intentionally say and confidently say, if you are implementing these things and making time for that in your lesson designing and planning, as well as when you're actually providing the lesson and then reflecting on how to really assess student learning and moving forward, then you can say that I am actually using culturally sustaining pedagogy while maintaining this universal design for learning principles. And let's see. Oh yeah, if anyone's interested in reading the article, you may have to purchase if you don't have access to this website, but you can probably find it in other ways. So I just put the link in the chat.
I also shared another link for this that we did a project with that focuses on math and culturally sustaining pedagogy. So we developed a lesson plan template as well. So if you want to take a look at some of those resources as well, so yeah.
Awesome. Thank you. I love that. Everybody's a math person. So I'm glad you're sharing resources. I'm gonna do one more resource and then we'll go into our share out or further reflection if needed. So this woman, Dr. Catherine Yee, is actually providing a session if anyone's interested in registering for that, and you can learn more from the reimagining of mathematics and not just middle school, but elementary as well.
She was actually the closing keynote at the Asilomar. If you're a math teacher, you know about the Asilomar Math Conference. But she was a closing keynote speaker there, and she mostly focuses on elementary. But I just thought she was amazing, and so we wanted to pull up some of her material to reference for this workshop.
Okay, so how did we apply these frameworks during this part of our lesson? So the framework that has been provided already for you on the previous slides, And how might you incorporate Dr. Bolawini's work and or culturally sustaining UDL into the content standards for your curriculum? So those are things for you to reflect on when trying to support students in their learning, not just in math, but any content areas.
I don't know if the folks here want to share out because I think all of you.
Okay.
All right, so we won't go to breakout rooms. So the last part of this workshop is a lab, and I'm just going to kind of run through the lesson remix lab for people who are watching this as a video, because you can still do the lab on your own. But basically, as Tamara and I were writing these lessons, we went through a 7-step plan for remixing the lessons. And so our first step, of course, was to identify the social injustice. And the first one we identified was AI image generation and how it doesn't include everyone's identity, right? And honestly, like personally, I identify social injustices all the time. Like they're always popping up, and I always say, I wish I could develop a math lesson on that. And it doesn't always connect. I can't always connect relevant content standards. So I kind of have these things floating around in my mind. But once in a while, I look at a content standard and I say that connects to this thing. So that's kind of step 2. And that was that probability number line task that we did earlier. Step 3 is to establish your goals. So I'm talking now about the lesson 1 we did with AI image generation. And we came up with a goal there to have students question the misalignment between their AI image generation experiment and what theoretically should have come up for a California student. So that was our goal. Our assessment was the closure question. So that would be step 4 is to determine your assessment. Then step 5 is to create the lesson itself, or create the social justice question for the lesson. And step 6 is designing the lesson. And we want to make sure that we incorporate UDL elements in our design. And then we always want to make sure we give students some type of action that they can do. If we are going to talk to them about a social justice issue, they need to know what they can do about it at the end. And so that's an important step 7, not to just leave them hanging and say, hey, there's something wrong with the world. Sorry. So this 7-step plan is actually not mine. It comes from Robert Berry and Company's book on designing social justice lesson or mathematics lessons for responding to social justice, and this is for high school. So Catherine Ye wrote the elementary school version of that. And these are all math people. So if you're a math person, like you know of these people. So from there, as Tamara and I talked about how we wanted to do this kind of lab portion of the workshop, while we did not use AI ourselves to write our lessons, we thought to ourselves, couldn't we use AI to help us kind of walk through the 7-step plan if we wanted to? And as it turns out, like there's this new thing in Gemini called a gem that you can create. Like you can code a gem to do a workflow for you. So I kind of went through and I typed up this 7-step plan and I threw it in to Gemini and it created this lesson remix thing, and it called my gem an opal. I don't know if it calls all of them opals because this was my first time doing it, but I came up with this opal, and these are the steps of it. I'm going to go to the Gemini tab right now so you can see what it looks like. And so it prompts you, you click the start button, and it takes a while. It takes a long time to think about things, so I'm not going to go through it step by step, but if you type the if you hit the start button and you type your social justice issue, I typed in algorithmic bias and I went through, it takes a considerable amount of time to think between each step, but I kind of prompted it to have a conversation with the teacher and help the teacher and ask the teacher certain questions. And then at the end, it spits out something for you. And let me go back to the slide. So, um, like I said at the beginning of this workshop, I just took a job teaching high school statistics. So I was curious at what it would help me create if I typed in standard deviation, like for the content area of standard deviation. And it gave me something that was pretty decent. It needs definitely some adjustments, but the guiding question here is how can the statistical concept of standard deviation help us uncover and critically analyze the presence and impact of algorithmic bias in real-world applications like small business loan approvals, and what ethical responsibilities arise from such findings? There is actually a lot of data out there to show that these AI tools and AI tools are used to approve loans. So there's a lot of data that shows that there is bias there. And I liked a lot of things about the remix lesson that I got. I actually like the idea. I said, oh, yeah, that is something I can talk to students about. We can talk about loans. I have high school seniors, so I don't know, maybe they'll get their first car loan at some point. And maybe they need to understand like these topics. These are definitely relevant to them. So the lesson plan looks pretty legit. One of the things I did not like is that it gave me a synthetic data set. And I actually had it to look specifically at small business loans. And I asked it, I said, hey, can you give me a real data set? And they said, no, there's privacy issues there, and we are not going to give you a real data set. And I thought to myself, okay, but this has been published that there's bias, so the data set has to be somewhere out there. So I had to dig a little bit deeper into this myself, but I was impressed just kind of with the outline I got. In the conversation I had with AI as I worked through the Opal, I told it I wanted my students to use CodeApp as they went through. So that's why that's in there. So that is a tool that we've created for you. We are giving you access to that Opal. And if you want to take a look at the full lesson plan, it's there as well. So since our only teacher dropped off this call, we're not going to actually run through the lab, but it is here. And as you run through this, I want to give you some ideas of topics you might consider. You might just start with the topics we did in this workshop, like bias in AI image generation if you're a third grade teacher and you want students to do some writing around it, like maybe you can throw that in as an idea. We talked a lot about Joy Buolamwini's research. I think it's very powerful to show that Ain't I a Woman visual poem. So thinking of how you might incorporate that. The Black Panther scorecards, I think, can be popular with students if they like the movie Black Panther. And like I said earlier, that AI for Oceans like curriculum that's out there, I think it's really good for talking about training data and bias. And then this AI bias in lending decisions, I got that idea from Gemini. And one of the things I specifically have been thinking about myself are some of the AI tools that are being used in healthcare to make diagnoses and like how they're leaving people out. And I haven't figured out a lesson yet for teaching that connects with math, but eventually maybe I'll get there. So there's some ideas for you. One of the things that is not an AI bias related thing, but is an ethical issue is just the human cost of AI training in general. there have been a lot of documented cases of the AI moderators who have to filter through like inappropriate AI content, um, are having PTSD symptoms because they're having to be subjected to like images over and over again, like of rape and violence, like because they are supposed to be filtering this out of our AI. So that's another kind of ethical topic that can be explored. But we are now at the closing. We're not going to do a lesson share out. We'll just leave you with some reminders at the end. Um, so first thing, student identity is really important. So as you're developing your lesson, um, how are you allowing for student voice and kind of getting their identities in the lessons themselves? Equity, like how are you ensuring equity within the lesson? Are you really intentional about getting students to think about the limitations of AI? And then if you're using AI as a lesson planning partner, are you thinking intentionally about those limitations as well? AI is great for a lot of things, but we want to think about the limitations as we use it. And then what's the best way to acknowledge and take action to correct disparities? I think you do a disservice to students when you tell them there's a problem with something, but you don't give them something they can do about it. So I've said that several times that they need to be able to do something about it. And so that is it. I am Crystal, and this is Tamara, and our contact information is here. And we've been talking about Joy Bolamwini all this time, so we're leaving you with one last resource, which is her book, Unmasking AI. It was part of Silicon Valley Reads. It was a recommendation for 2025. So
This is great.
is
Thank you so
it.
much both for being here and for doing this. I think I certainly learned a lot and a lot of really great resources.
Thank you.
Oh, thank you.